In our third video, we're going to start talking about the concepts of emerging disease and re-emerging disease and give some examples. So when we're talking about an emerging disease, this is a disease that's either new to humans or there is an increased prevalence in human populations where it did not previously exist. It's a disease that's new to humans, or there's an increased prevalence in human populations where it did not previously exist. And I'll expand on that a little bit. Some of the emerging diseases that you might be aware of, the avian influenza, the bird flu, swine flu, the one I said was around 2009, but that can come around again. You might have heard of Zika virus in the news, or MERS, and SARS-CoV-2, the virus that causes COVID-19. These are all have been emerging diseases in my lifetime. Maybe not all of yours, but definitely in mine. And how do we get new diseases? A lot of times it's due to exposure to animals, but sometimes it's also due to mutations. So we were talking about how the influenza viruses mutate very easily. And so, if we talk about emerging disease, a re-emerging disease is a disease that's reappeared after a significant decline in incidence. So the emerging disease is new, or it's just kind of being found somewhere it didn't used to be found. A re-emerging is, oh, we used to have that disease, but it went away and now it's coming back. Some of the streptococcus infections caused by the bacterium streptococcus, are re-emerging because there are antibiotic resistant forms that are evolving. And so we used to be able to get rid of these infections really easily. Now they're becoming antibiotic resistant, so they're becoming more common again. So that would be re-emerging. Here's a big one in 2025. Measles was literally eliminated in the US in the year 2000. There were no cases of measles. And now you get years beyond 2025, the people are thinking, oh, well, the measles vaccine, they're bad. They're doing bad things, which is not supported by any scientific facts. But some people decide that they shouldn't get measles vaccines. And on top of that, a lot of people have never seen a case of measles, so you don't realize that it can be a serious disease. So there's not the urgency to do it. But it turns out in 2025, measles is re-emerging in the U.S. due to international travelers bringing it to the U.S. and then unvaccinated people becoming infected. So that's another way to get a re-emerging disease. Let's look at some of the examples. West Nile virus came into New York City from I can't remember what country, but they kind of traced it to mosquitoes coming from some shipment of products from a country in Africa, and brought the mosquitoes were released from the shipment of whatever it was, produce or whatever, and spread West Nile virus in the U.S. So now we have that in the U.S. It was an emerging disease. It was a brand new disease. Here's the H1N1, that virus, the swine flu virus. Some of you might have heard of Zika virus. Zika virus was a virus we just didn't know about. I don't know if it had been around before, where it came from, but it's something now that people are concerned about. It's a mosquito spread virus. Here we have Ebola, an emerging disease. It causes you to bleed out of all your openings in your bodies, and it has a very high death rate. But you can see a lot of emerging. Oh, here's our SARS-CoV-2, or COVID-19. It emerged in China, and it appears to have come from animals that were in a market being sold. So they go into the jungle areas, and they trap animals and they bring them out into a population with all these people. People have never been around these animals, and they can spread diseases. So those kind of things happen. So these are all different emerging diseases. One of the emerging diseases we mentioned over here was that SARS-CoV-2. And here's another one called SARS. And there's another one called MERS that I'm going to mention. These are all coronaviruses. So my next outcome says recognized examples of coronaviruses and how they relate to recent epidemics and pandemics. So here's a really beautiful picture of a virus. It's an electron microscope picture, and it's been colored with a computer colorized. So, but here's you've got I think this is the envelope. This virus has an envelope. And then these red things are the spikes on the outside of the virus. But coronaviruses are a family of viruses, and they have a crown-like appearance. So these spikes make it look like they have a crown. Corona means crown. And so there's a family of viruses that look like this, and these viruses are common in animals. There's a lot of different kinds of coronaviruses, but there's 3 that have made news in the past couple decades. SARS-CoV. SARS-CoV is the name of the virus. It first appeared in China in 2002. It was transmitted from animals to humans. They believe it was bats. And there's these things that kind of look like raccoons, but they're called civet cats. So if we look back here as an emerging disease, there's the SARS. They say 2003, whatever. 2002, 2003. The SARS-CoV first appeared in China. And that also came from animals, just like our COVID-19 virus. There were about 8,000 cases worldwide. 774 deaths. The mortality was around 10%. That's pretty high. But there have been no human cases since 2024. It was a pandemic, but it was controlled by public health measures. When you have a 10% mortality, that's pretty high. You and 9 of your friends got the virus, one of you is going to die. So this is a pretty serious high mortality rate. But that pandemic, just by isolating people and controlling it, the virus kind of just died out. It just wasn't able to continue to pass from person to person. But it did become a pandemic. And that was a coronavirus, SARS-CoV. The second one I want you to notice is called MERS. And MERS was Middle Eastern respiratory virus. Oh, this is, Middle Eastern respiratory virus. MERS, Middle Eastern respiratory virus. SARS is severe acute respiratory virus. So, so then there came this thing called MERS about 10 years later. It was in the Arabian Peninsula, and they also think that came from animals, from bats and camels to humans. And it sounded kind of weird, like, why do all these things come from animals? Well, we're exploring. We've got more people on the planet. We're using more land on the planet. We're looking for other sources of food. It puts us into contact with animals that were very isolated before that. So by the end of 2019, there were about 2,500 cases of MERS with 858 deaths, 34% mortality. A third of the people that got MERS died. That's really high. It never became a pandemic. It was kind of isolated to this Arabian Peninsula area. And it says the epidemic entered because of limited human-to-human transmission and public health measures. This virus just didn't pass from person to person very easily. It wasn't super contagious. I mean, obviously it was contagious, but it wasn't really easily transferred from person to person. So again, that virus kind of just died out. It wasn't transferred very well. And that was fortunate, because with 34% mortality, that's really high. So that leads to the third coronavirus I want to mention was December 2019. We have a severe acute respiratory virus, just very similar to the original one, SARS-CoV, but it was a little bit different. When you study it, you get it into the lab, you find it was a little different, so they called it SARS-CoV-2. That's the virus that caused COVID-19. And this caused a global pandemic, as we all know. And the main reason was it's more contagious. than MERS or SARS-CoV. So it turns out it wasn't as deadly. It had about 7 million people died worldwide, but the mortality was only 1.7%, which tells you a lot of people got this virus worldwide. So the mortality was much lower, but it was much easier to transfer from person to person, which is why this became a pandemic and these did not. Well, this one was a pandemic, I guess, but it wasn't quite as extensive as SARS-CoV-2. The pandemic was controlled by public health measures, and the biggest thing that controlled that was vaccination. If you do the math and you assume that everybody is capable of getting this virus, even if you have a low mortality, you end up killing a lot of people for something that's very contagious. So anyway, these are all coronaviruses, and they've been really important in the world in the past 20 years. So how do we, it says, give some recommendations as to how to reduce the threat of emerging diseases. So how do we protect ourselves from these potentially very deadly or very contagious diseases? One is to be aware of what's around. Healthcare workers worldwide should be looking at outbreaks and epidemics and trying to figure out what's causing this, where is it coming from. So all that kind of surveillance, quarantine people that get it. When people, there were people that got SARS-CoV that were being isolated to prevent the spread of that disease, and it got in the news because people didn't like being isolated and not being able to mingle, with other people. But that's what helped contribute to preventing this from spreading farther. So quarantining people, development of vaccines is really critical. We would have lost a lot more people to COVID-19 if it weren't for vaccines. And for bacterial diseases, which we'll talk about in a minute, proper use of antibiotics. If you're using antibiotics correctly and at the right dose and treating diseases early, antibiotics can be a great way to get rid of diseases. The problem is antibiotics don't work for viruses, and I'm going to mention that soon. So our whole thing with coronaviruses, there was no drug that you could give everybody that was available to kill the virus because we don't have antibiotics against bacterial diseases like that, against viral diseases on hand. Okay, I'm going to stop right there, and we have one more section to talk about.